In this section, we talk about how to multiply, add, subtract, divide, sort of basic arithmetic operations on rational functions. So, let's go through a example of just actual arithmetic, and then we'll see how it translates or how it relates to the algebra. Expressions. Okay, so let's do 12/15 plus, this isn't reduced, but that's fine. Let's 7, say 24ths. Okay, so the first thing we need to do is we need to find a common denominator. And to find a common denominator, well, we look at both of the denominators and see what factors they have in common. So when we do this with algebra stuff, we're going to have to factor the denominators and see what factors they have in common again. So let's rewrite this with common factors. We'll factor everything out. So I've got 2 squared times 3, which is 12, divided by 3 times 5, plus 7 is prime, so it sits there by itself. And then I've got 2 cubed times 3. 8 times 3 is 24. So I've broken this all the way down into prime factorization. And now we get to pick out common factors, right? So I've already got a 3 in both of them. This has a 5 and this has 3 2's. So to get common denominators, if I want a 5 over on this side, I'm going to have to multiply the top and the bottom by 5, right? So let's do that here. So we're going to multiply the top and the bottom by 5 so that I have a 5 in the denominator there. And on this side I need 3 more 2's, so I'm going to multiply the top and the bottom by 2 cubed so that we have a common denominator of 2 cubes times 3 times 5, right? So that changes this to 2 to the 5th times 3 over 2 cubed times 3 times 5 plus, I'm going to write them in increasing order, 5 times 7 over 2 cubed times 3 times 5. And now that we have a common denominator, so say for example if it was fifths, I would have some number of fifths plus some other number of fifths. And so those fifths are like units in some sense, like 2 feet plus 2 feet is 4 feet. Well, I've got fifths plus fifths is some other number of fifths. I can just add the tops because that tells me how many number of those fractions we have. So this is going to be 32 times 3 is 96 plus 5 times 7 is 35 divided by 8 times 3 times 5 is 120. So if I add this up, I get 131 over 120. And there we've got our addition of fractions, right? Okay, so now let's do addition and subtractions the same way. You find a common denominator and then you add or subtract the tops. So let's do this with a actual rational expression. So same thing with subtraction, right? We just find a common denominator and we add or subtract the top. So let's look at x minus 1 squared, x plus 1 over x plus 2, x plus 3. And then we're going to add to that, let's say, x minus 2, x plus 1 over x plus 3 squared times x minus 5. Okay, so we've got sort of the same setup again, and we've got everything in factored form, so I don't actually have to go through, like with the numerical one, it didn't start out in factored form. I had a 24 and I had to put it into factored form, and I had a 15 and I had to put it into factored form, right? The 24 went into factored form there, the 15 went into factored form there. Okay, so we've already got everything in factored form, so I don't have to actually do that factoring stuff, but what I have to do is I have to find a common denominator. And so which factors do I have? Let's just write down the common denominator first. I need an x plus 2 in the denominator because there's an x plus 2 there. There's no x plus 2's over here, but that's okay. This is going to go in the denominator. I'm going to need an x plus 3. I actually need 2 x plus 3's, right? I have one here, but I need 2 of them there. Just like including 3 2's here, if there was already a 2 over here, I just need to bring it up to having 3 2's. So I'm going to need to bring in an x plus 3 squared. This is already in the denominator, so this x plus 3 already there. So to get this one to have an x plus 3 squared, I'd have to multiply the top and the bottom by an extra x plus 3. Okay, and then the last thing I need is an x minus 5. Okay, so that's going to be the denominator of my fraction. Over here, let's actually get this denominator for both of these fractions. So I've already got an x minus 1 squared. I've got an x plus 1 in the top already. I have the x plus 2 okay. I need another x plus 3. That's what I have. So what I need here, remember we did this in green last time, I need another x plus 3. So I have to put an x plus 3 on the top and the bottom. And I need a x minus 5. So I need an x minus 5 on the top and the bottom. Okay, that takes care of the first fraction. I've got my x squared, my 2 x plus 3's, and my x minus 5. So those denominators, these two denominators, they match up now. I have to take care of the second fraction. So I've got my plus sign, and now I have to take care of the second fraction. Let's write what we have already. I've got the x minus 2, I've got an x plus 1, I have an x plus 3 squared, I have an x minus 5. Okay, so in green we'll put what we're missing. What are we missing? We've got that already, we've got that already. I need this x plus 2. So we're going to put an x plus 2, top and bottom. Okay, so in a sense I'm just multiplying by the 1 on top and bottom. I multiply by something and I divide by it right away. It doesn't change the actual expression. So this equality still holds. Equality is important. We don't want to change anything, but we can change how it looks. We can put a hat on it, right? We can change its appearance a little bit by adding or multiplying by 1 in this case. Okay, so now I've got this proper denominators for everything. So what this is going to look like as a fraction is I've got x minus 1 squared, x plus 1, got x plus 3, x minus 5, I've got my addition, and then we've got these other 3 terms. I've got x minus 2, x plus 1, x plus 2. Okay, so that is my addition of those 2 rational functions. If these things were a lot smaller, maybe I only had 1 term to multiply instead of 5 terms here and 3 terms there, I might expand this out and then add them together. So let's do a smaller one where we actually do everything. We'll do subtraction this time. Okay. Let's take x minus 1. over x plus 2. We're going to subtract from that, let's say x minus 3 over x plus 5. Okay, the common denominator is a lot easier to find this time because I just have two factors down there. I've got an x plus 2 and an x plus 5, so my common denominator is going to be x plus 2 times x plus 5, right? And if this was like 2/3 plus 3/5, right? These don't have any common factors, so I just multiply them together, and 15 would be my common denominator. I have two terms here, no common factors, so their product is my common denominator. So let's write that out. So I've got x minus 1. I need an x plus 5 in the bottom and the top. So we'll multiply by x plus 5 over x plus 5. We're going to subtract from that. I've got the x minus 3. I have the x plus 5. What I need on this one is the x plus 2. So we'll multiply it by x plus 2 on the top and the bottom. And now we'll expand this one out. So x minus 1 times x plus 5, if we FOIL this out, right, we're going to end up with x squared plus 4x minus 5. And that's that numerator. I can put this all over the same denominator now. So I've got x squared plus 7x plus 10. This is in parentheses because it's the first fraction. That first fraction, I am taking away this stuff, which I'm going to put in parentheses because I'm taking away all of this stuff, right? So this stuff is going to go here. I've got x squared. FOIL this out, you're going to have a minus x and you're going to have a minus 6. So we're going to take away all of this from this, and then we'll simplify. So I've got an x squared minus an x squared. Those go to 0x squared. I've got 4x minus an x, so that turns into a 5x. I've got a negative 5 minus negative 6, that turns into a plus 1. So I've got 5x plus 1, and we can write this as x squared plus 7x plus 10. Okay. So this equals that. And that's how we do addition and subtraction of rational expressions.